Welcome to part 2 of training for the PM10K Plus sensor. The PM10K Plus is a laser sensor that delivers power measurements of high-power lasers in under 3 seconds. Part 1 demonstrated how to unpack and set up the sensor for operation. This video demonstrates tasks to operate the sensor to evaluate cooling water flow and to observe laser measurements. For information about how to unpack and set up the PM10K Plus, refer to part 1 of this 2-part series. Topics covered in this training include: adjust the aiming beam, start, and then adjust water supply conditions, as necessary. Start data collection and observe and capture measurements. At the same time, we will adjust conditions, as necessary with use of the Coherent Meter Connection software. Lastly, we will disconnect, drain and stow the PM10K Plus sensor. Please refer to the PM10K Plus operator's manual for complete safety precautions before any work is done with the sensor. The procedures shown require the following materials and tools: available source of facility water input and output with adjustable flow and temperature controls, hex drivers, as necessary, to adjust the position of the sensor or remove it from the mount. Coherent Meter Connection software installed on a workstation or use of an external power meter. Sensor is fully installed with water, power and communications connections. If a guide beam is available, alignment is done to assure good position of the laser on the absorber surface for accurate measurements. Use extra caution and make sure that the laser beam diameter is appropriate for the anticipated laser power. Make sure that the beam is not too big and does not clip the aperture. Make sure that it also is not too small, which can damage the sensor coating. Note that the aiming beam cannot be relied upon to give the true laser beam diameter. The true beam profile depends on the specifications of the laser and delivery optics. Remove the protective cover from the sensor absorber surface. Set the aiming laser to on with the software used to operate the laser. Look at the visible aiming beam. Make sure that the beam is in the center of the absorber surface. If necessary, adjust the mount hardware for the sensor until the beam displays in the center of the absorber surface. Please note the following caution. Objects near the sensor surface in the line of sight of the detector can cause backscatter or can retro-reflect back towards the sensor, resulting in measurement error. As necessary, move hardware or objects to block or avoid any retro-reflection and then set the aiming laser to off. Please note that the following demonstrations show the use of a USB version of the sensor. It is used with a PC workstation with a Coherent Meter Connection software. For instructions and examples of use of a standalone power meter, such as a Lab Max Touch or Touch Pro to observe flow conditions and laser measurement, refer to the PM10K Plus operator's manual. Also, refer to the operator's manual for the specific meter being used. The pulsing or blinking and color of the LED indicator communicates useful status information. A slow pulsing light shows that the sensor is connected to the host PC via USB or RS-232. It is idle and data is not streaming. A rapidly blinking light at 10 Hz indicates that the devices are communicating and measurement data is streaming to the host PC. A static on light shows that communications are active and the device is connected to a compatible standalone meter via the DB25 cable. Note that water chiller control images are for reference only. Gauges and controls will vary depending on the end user facility. Note that with no water flow to the sensor, the LED displays a solid red color. Make sure that the water source is set with a flow rate at 1.5 gallons per minute, or 6 liters per minute. Also, make sure that the temperature setting at the water source is within specification of 10 to 25 degrees Celsius. Set the water supply from the water chiller to on. The most accurate measurements are made when cooling water temperature and flow rate are stable. Check for possible leaks at the sensor water ports. Look at the sensor indicator light. It should display a blinking red and then yellow color as it comes up to correct flow. Then, it should become a blinking green as it reaches correct flow levels. See the example here. Again, a slow pulsing LED pattern indicates a valid communications connection to the host PC. When flow and temperature conditions are correct and within specification, click the 0 button in the software to set the sensor to 0. Click the Start button in the software to start data streaming. Note that the top of the screen will show any indicators for fault conditions as warnings or cautions, that also shows a description when the mouse is hovered over. See the example here. The CMC software will at first show a red unstable flow warning or a yellow low flow caution indicator. Indicator flags in the upper right of the CMC screen will indicate low flow fault and warning conditions before water flow is established at correct levels. They display in the upper right corner. The diagnostic window aids in displaying the real-time inlet flow rate and water temperature. The LED indicator on the sensor should show a very rapid blinking light. This indicates that measurement data are being streamed to the host. Note that when a standalone meter is used, and not a host PC, a static persistent LED will be observed. In the Software Diagnostics tab, the green line shows the water flow rate. The blue line shows the water temperature at the inlet. If there are changes in flow rate or temperature that result in on-screen caution or warning indicators, adjust the water flow rate and temperature from the facility, as necessary. The sensor provides an accurate measurement of the flow rate when using Coherent Meter Connection through the USB or RS-232 interface. Otherwise, an external gauge can be used to determine the cooling water flow rate. This example shows a low flow or no flow warning condition on screen that must be resolved. At the same time, the LED on the sensor shows a red blinking light. To resolve this, make sure that there is water flowing from the water chiller and that the flow rate is correct. Also, make sure that the water hoses are not connected in reverse. Note that, depending on user settings in the software, the scales on the displayed graphs can auto-scale as levels ramp up or down, for improved views of the trending data. As the flow condition becomes within specification, the on-screen indicators go away. Also, the LED indicator on the sensor changes to green. The equipment is now ready to take laser power measurements that are streamed from the sensor. Note that these examples show a setup of the standard PM10K Plus sensor model with a USB interface. Be sure that water flow is still correct and within specification. Another example here shows a situation that has a low temperature caution condition that should be resolved. Adjust the water temperature at the source such that the range is within 10 to 25 degrees Celsius. When all conditions are correct, laser measurement can be done. Set the laser to on. The Trending tab in CMC allows for real-time charting of the laser power measurement. The power reading should become stable as the trend line increases and then becomes flat. Measurement detail values display in the right panel. At the same time, the LED indicator on the sensor should display a rapidly blinking green, unless a fault condition occurs that results in a caution, yellow, or warning, red. To view water flow and temperature measurements again, click the Diagnostic tab. When done, set the laser to off. Then click Pause in the software to stop data streaming. The resulting capture buffer can be exported to a file. Next, set the water flow at the chiller water source to off. The LED indicator should change from green to yellow, and then to red. See the example here. When using a standalone meter with a display for laser measurement, the sensor's water flow condition warnings are limited to the LED indicator on the sensor itself. The meter does not provide flow rate warnings. Nevertheless, the meter offers excellent functionality for viewing and logging the laser power measurement. Note that both Coherent Meter Connection software and an external meter can be used at the same time to measure laser power, as shown in this example. We will now demonstrate how to disconnect and stow the sensor. Slide the protective dust cover over the sensor. If an RS-232 model is being used, disconnect the power supply cable from the sensor. Then, for any sensor model, remove all communications cables. Use care not to spill water when hoses are disconnected. Note that if there is residual water pressure in the cooling lines, some amount of water can eject when the hose is disconnected. Use of a towel is recommended. Disconnect and remove both water tubes. Press in on the rings of the push-to-connect fittings and pull the hoses or hose adapter fittings to remove them. Use a towel to capture any water that spills out. Carefully loosen the mount hardware and hold the sensor steady so that water does not spill out. Carefully remove the sensor and move it over a bucket or sink. Carefully rotate the sensor so that the water flows out and drains completely. Do not use air blown into the device to attempt to dry it out. This can damage the internal components. If the sensor is not in use, reinstall the protective caps on the water inlet and outlets. This completes the training to prepare to operate and to operate the PM10K Plus sensor. For more detailed information, go to www.coherent.com/resources and search for PM10K Plus.